What's going on, you guys? Mr. Allen here. We're about to expand this dope binomial here, raised to the 6th power. Whew! Man, I got a few options here. I can write it out 6 times. That's a fool's game, man. Or I can use binomial theorem to get my numbers from Pascal's triangle, or I could write out Pascal's triangle. Now, if I'm taking a test, I'm probably doing quite a few of these, so I'm just going to write out the first 6 rows of Pascal's triangle because I'm probably going to use it later on anyways. Let's do it. We got 1, 1 and 1, 1, then 2 and 1. Boom, look at that. No time at all, right? Now I got it for any problem that I'm working with through this test. So we got that last row that we're going to be using there. Last row, I'm going to have that 1, 6, 15, so on and so forth. I'm going to spread it out quite a bit. So I'm going to use this whole thing. I'm going to use this whole thing. We're going to have 1, we're going to have 6, 15, 20, 15, 6, and 1. Woo! Oh, man. Oh, man. I'm going to get colorful with this one. I'm going to get colorful. All right. So we're going to work our way down, right, with that first term there. The 2x will be raised to the 6th power, and then going on down from there. So we're going to have 2x raised to the 6th, and then 2x raised to the 5th. All right. Next one up, we got the negative y, okay? And it's important that we include that negative because that is going to alternate our signs throughout this whole expanded binomial here. So we got negative y raised to the 0, negative y raised to the 1st, and work our way up. There we go. Woo! Man, I'm getting excited. I'm doing a lot of woos because I'm excited, man. All right, let's see here. So we've got 2 to the 6th power. Well, 2 to the 5th is 32, so 64. All right, so 64, that's 1 times 64 times, well, negative y to the 0 is just 1. So we're going to have 64 x to the 6th. All right, first one done, man. First one done. Next up, I've got 2 to the 5th, which I said was 32. 32 times 5. Let me just double check this here. I probably do that in my head, but I don't want to mess up in the video. You know what I'm saying? 36, well, 36 times, 32 times 6, not 5. Going crazy. We got 192. So let's see here. 192, right? That's going to be a negative 1 raised to the 1st power, which makes this one negative. Then I'm going to have x to the 5th, and we'll have y to the 1st power. I'm just going to leave it as y, right? We're not going to write that, you know, that 1 up there. That's weird looking. Okay, cool. So we got 32 times 6 to get that 192. Negative because of the odd power on my negative term. Next one up. I've got myself here 15, okay? Times 2 to the 4th. That's going to be 16 times 15. So 16 times 15, that gives me 240. 240. Negative 1 squared is positive 1. So we're going to be positive 240. It'll be x raised to the 4th power, and we'll have y raised to the 2nd power. We're cruising, man. We are cruising through this whole problem. All right, 2 to the 3rd. That's going to be 8. 8 times 20, that's going to be 160, right? 8 times 2 is 16. Pop the 0 on there. We got 160, but it is a negative 1 to an odd power. So it's going to be negative 160 this time. X cubed, y cubed. Now on to the next one. We got 2 to the 2nd power is 4. 4 times 50, that is 60. 4 times 15, sorry, I said 50. I'm saying a lot of weird numbers. 4 times 15 is 60, and it's going to be a negative raised to an even power, so it's going to become positive in that case. So we got positive 60 x squared y to the 4th. Let's see if I can nail this next one here without any misspeaking. We've got 6 messed it up. 2 to the 1st power is 2. And I got a negative to an odd degree, so that's going to be negative. So we have 6 times 2 is 12. Make that bad boy negative. I got negative 12, x to the 1st. We're going to leave that 1 off, and we get y to the 5th. Last one here, my last chance. We have 1 times a negative 1 raised to the 6th power. It's an even degree. That's going to be positive. So I'm going to have plus, we got 1 y to the 6th power there. Woo! Almost messed it up, almost, but man, that's it. I don't have anything else to do. So I can just go ahead and box this thing. Boom. It's a long answer. Now, before we finish here, okay, because there's a couple important things to talk about here. And we were talking about like with a test, right? And writing this bad boy down here for a test, right? So questions we can ask on a test, because I don't know about you, but I don't want to grade that, right? I don't want to grade this here and look at all those things. I'm going to go crazy looking at 100 of those as I'm grading tests. So us teachers, we come up with crazy things to do. I might be like, hey man, multiple choice. Which of the following are terms of this binomial expanded. And perhaps in the multiple choice, answer C might be negative 160 x to the third y to the third. Select it, right? And it might be a select all that apply. I don't know, man. Maybe we're crazy. And you see y to the sixth is one of the answers there. And then maybe there's also one that just says like y to the fifth. And you're like, that's not a term, right? Y to the fifth is not one of these terms. It's sitting there, but it's not one of the terms because it's connected to all that other stuff. Okay, so that is a common way to ask this question without having to have us grade this entire thing, but you still have to expand it. How evil, yes, right? We make you do all the work. I didn't have to grade it all. All right, just being creative. And then I think that'd be about it. Might ask you maybe a question, like what's the coefficient of a particular term, but then you can probably use binomial theorem. But again, multiple choice question, a select all that apply, definitely something that can happen in one of these bad boys. Write out your Pascals, that's super helpful. And I think I'm done here. I think I'm done. Have a great day.